This video will show you how to look at function intervals and decide whether they are increasing or decreasing. So let's first talk about what the difference is between increasing and decreasing. So intervals are considered increasing if the y values increase as the x values increase. So as our x values go from left to right and they get bigger, our y values should also get bigger. So in this example, the y values start here around 2.5 and they keep going up. So this shows us that this entire function would be increasing. Intervals are considered decreasing if the y values decrease as the x values increase. So we'll still look at the x values from left to right, but if our y values are declining and they go down, then the whole function is considered decreasing. Functions can change between increasing and decreasing, so that's why we use intervals to identify the patterns. So let's look at this first one. So let's talk about where it's increasing and where it's decreasing. So at our starting point, wherever the arrow is, we can see that it's increasing all the way up until we get to 0. So we can say when x is between negative infinity, because we're not sure where their starting point was, when it's between negative infinity and 0 on the x value, then it is increasing. On the other side, let me switch my pen color. Okay, so from this 0 after it was increasing, the rest of the time it's going to go down. So this tells us from 0 to positive infinity, it is decreasing. And this is how we will write intervals and decide whether they're increasing or decreasing. We'll put the value x in between the boundaries of where they're increasing and decreasing. Okay, let's look at the next example. So let's first talk about where it's increasing. So where does it start to go up from left to right? So look, this is a quadratic equation. So it just tells us it's going to kind of be a mirror. And that mirror happens right here when x is 2. So from x is 2 all the way to positive infinity, our function is increasing. So we can write that as x is in between 2 and infinity. And then we just put the greater than or equal than signs. Okay, now let's see where the function is decreasing. Okay, so the function is decreasing up here at, well, it's going to go on forever, so it's really at infinity. And then it's going down all the way until we hit that 2. So we would write it as negative infinity and then 2. So any values between negative infinity and 2 will show that our function is decreasing. And then any values between 2 and positive infinity will be increasing. So that's how we'll write the intervals for these functions. Okay, so I'm going to do example 1 and you'll do example 2. So we'll just do them at the same time to make sure the steps are lining up. Okay, so example 1 says, where is the function increasing? So I want to know where is it going up as x goes from left to right. And we can see that it's going up until we hit this point right in the middle. And that looks like it's at -1 on the x-axis. We don't know the smallest point because it's an arrow, so this tells us it's negative infinity. So we know it's increasing between negative infinity and -1. Okay, so we're going to also look for example 2, where is your function increasing? So it looks like this is where it starts to go from down to up, so it's increasing along here. So how would you write the interval for where your function is increasing? Okay, let's look at the smallest value it starts to increase and the largest value. So the smallest value it increases is let's see, this is 0, so -1, -2, -3. Okay, so -3 is the smallest boundary, and then it goes all the way up to infinity. Okay, so between -3 and infinity is where your function is increasing. So this is what you should have had as your answer. Okay, now let's talk about when our function is decreasing. So again, I'll do example 1 and then I'll leave example 2 up to you. So we're talking about where is it decreasing. Okay, so I can see it's going down on this example, and it decreases until we get down to 0. So we know that so we're always looking at the x values. So the smallest is going to be -infinity. We don't know where it ends. And then the largest number it's going to stay decreasing is at 0. And then we'll just put our x in the middle. Okay, so for your example, we're looking where it's decreasing also. So it's decreasing along this line as it goes down, and then it stops here. So which interval do you think your function is decreasing on? So this example is kind of like mine. So the smallest x value would be -infinity because it keeps going. But it stops right here where x is equal to 2. And then we just put our x in the middle. Okay, so some functions have a little bit more than just one, like 2 patterns that are happening. There can be a lot of different increasing and decreasing intervals going on. So let's look at example 1. Where is the function increasing? So a couple patterns going on. Okay, so it starts to go down, and then it starts to increase right along here, and then it starts to go down again. So we're only focused on where the red is. That's where the function's increasing. So I'm going to put the 2 boundary lines so we know where it stops. Okay, so my interval, I'm going to write my x first. So it's between -2.5 and then it ends at 1.5. And then the other parts of the function would be decreasing. Okay, so for example 2, where is your function increasing? Where would you put your interval? So I'm going to highlight where it's increasing. So it starts going down, and then it starts to go up right around here before it starts to go back down again. So I'm going to just outline that again so we can see it a little better. Okay, so the function is increasing between -2.5, and then it stops right on the axis at 0. And then we just put our x in the middle. So that is the interval in which this function is increasing. Okay, a little bit more patterns going on, and this one says where is it decreasing. So for example 1, I'm just going to highlight where it looks like it's decreasing. So it starts to go up, and then we can see it going down until we hit the axis at 0. And then it goes up again, and then we see it decreasing again. So we can see that red line is where it's decreasing. Now we just have to put the intervals. So we're actually going to have 2 separate intervals for this one because it kind of takes a break. So our first interval would be between -2 and 0. And our second one happens between 2 and I'm going to say about 5. I can't say infinity because it looks like this might curve up. So since we don't know the exact end pattern, we'll just stop it at 5. So it happened between 2 and 5 is where the function was decreasing. Okay, so let's look at your example. Where is your function decreasing? Okay, so I'm going to draw the red line where I see it going down. So it stops around -3 and then it goes up, but then it decreases again right here. So you should have picked 2 intervals, and it would have happened between x is -5 and x is -3. And then it happens again right here at -1.5 and then 0. Okay, so that's where your function was decreasing. Okay, just to summarize what we did, functions are increasing when their y values increase with the x values. Functions are decreasing when their y values decrease as the x values increase. And functions can increase and decrease at different intervals.